assembled here this morning to hear a presentation from Ritz company and to know what they have and their future development.
Good morning, Mr. Gambra. Thank you for the kind invitation that you allow us to be here, to be present. Good morning, distinguished ladies and gentlemen. Ritz Pump Manufacturing is a German company that is in existence for now 133 years. My name is Rainer Gianotta. I am the area consultant for the African countries. Important to me is I'm a consultant, that's how I see myself. What we do here today, in the very beginning, we start on the advantages of customized solutions compared to buying things from the shelf. As you can see, this is where our budget is seriously affected. This is where we can earn the money. This is where we go into the details why we should have tailor-made solutions. Money is all that business needs to take into consideration when you think in terms of purchase, in investment, and here efficiency plays a key role. As we can see, the life cycle cost of a pump system. A pump system consists not only of a pump, it consists of motors, pipelines, control panels and so on, valves, elbows, all of them predetermine where and under which conditions a pump may run. A general misunderstanding amongst young students, which I encounter frequently in Germany, is they think the pump is the governing effect of a system. Because you can crank up or decrease the power, they think you get more or less water out of it. We all know this is not the case. A pump is basically the slave of the system. The pipes, the elbows and all kind of frame conditions, the heads, the viscosity and every other side effects determine the conditions under which the pump has to serve. Now, as we can see here, energy in the life cycle of a pump system is the major factor. I read that power cost will increase to almost the double, it's 90 plus something %. And water will increase about 30 plus %. Which means for us here, producing water will be much more expensive. We have to pay way more on the energy side than we can gain on the water side. Now, the cost of a pump system consists not only of the energy cost during the run, some other operation costs like maintenance, people, employees, installation and startup cost. But the major factor, energy, will force us to look into very efficient technologies. Now, efficiency, and this is one always has to bear in mind. There is a general rule of thumb. If you have two different pumps, one gives you 3% higher efficiency, the value of the pump is paid off in about 2 to 3 years. Now, we talk in terms of high efficiency pumps that are designed for the very specific application. We do not recommend take anything from the shelf of some manufacturer because it happens to be there and use it because it might somehow more or less work in that installation. We do serious consideration of all the frame conditions. The more we know about your problems, the better we can come up with a solution that brings you about 10 to 15% higher efficiency than a regular run-of-the-mill pump in the system. And I don't speak only of the pump, I speak also of the coupling, the motor and the piping and the control systems. Now, if 3% pay off a pump in 2 to 3 years, you can calculate what 15% better efficiency can do. You pay much less in energy, in power, for the same quantity of water. Or if you pay the same amount of power, you sell about 15% more water. That pays off the price of a pump in about 4 to 6 months, easily. The second advantage of customized pumps, they live much longer, they are more reliable. Because if a pump suffers under wrong operation conditions, it may shake, rattle, the bearings might wear off, and the pump is done after 4 or 5 years. A tailor-made pump, as we have seen here, we have visited many stations here, where Ritz pumps are still in operation after 25 or 30 years, before we now replace them. Now this gives you peace of mind. If you don't have to buy a pump every 4 or 5 years, where you also have downtime cost. It's not the price of a pump alone that costs money, but if the pump breaks, you have downtime. You don't procure water, you don't sell water. This is a cost factor. If a pump is in service 25 or 30 years, this is what we would like to see, this is what we would like to recommend to you. Durability depends on the fact that the pump is detailed, customized for the application. Of course, a water analysis is very important. You find that also to be answered in the questionnaire, because depending on what kind of chemicals the water contains, of course, we have to choose different materials of the casings, of the impellers, of the sealings, of the bearings, maybe some lubricants that we change, that they are chemically resistant. Also the contents of solid materials. What kind of solid materials? How much? Because that affects the weight, the specific weight of the water. Then the motor has to be chosen bigger if the water is heavier due to solids. What kind of solids? Are they abrasive? What is the particle size? What kind of abrasives? Then you have to choose either a different impeller material, say aluminum bronze, stainless steel, or even duplex steel, sometimes full duplex if it's chemically aggressive also. Or in terms of chemicals, it's not always going into the more expensive side. It could also become cheaper. If there is certain chemicals consistent in the water, it could be that we downgrade, say for instance from aluminum down to grey cast. That is sometimes even cheaper. Now, what kind of pump technologies do we typically use here in water procurement? Sometimes as intake, we have for raw water submersible sump pumps. Quite standardly, we have for boosters a multi-stage pressure pump, high pressure pumps. Submersible pumps are very common in boreholes if you have water procurement abroad and the groundwater level is deep. There is different technologies and there is plenty more. Now, since Ritz is in operation for over 130 years, we have about 65 to 70 different families. If it's a replacement pump, what kind of pump is in operation? Not only if it's a Ritz pump, we have in our archives all kinds of different brands and know about the types. We know about the technical backgrounds. We would also, for instance, like to know how stable is the water level. Is it fairly stable, or do we differ during the rain season and dry season? Because we have for many different pumps, different hydraulics, different impeller systems. One, for instance, is very tolerant to water level changes, to head changes, but of course you have to pay a price for it. The flow changes also drastically. And the other pump, for the same duty point, but in a stable condition with little change of the water level, of the water head, is a very stable one in terms of flow, but very sensitive to head changes. So one has a steep curve, one has a flat curve. If we know the frame conditions, we can propose either the one or the other as being the best solution. Power outages is nothing to be ashamed of, but a pump and solution manufacturer should know how often could that happen. How often, how frequently a year, how stable is the power, the voltage, because every single time you have a power outage and shut it back on to service, either you have a start delta quick start, then the motor gets a real overcurrency and an overpower, which can damage, and we have to select the bigger size engine, or we do a soft start, or we have a voltage regulator within the control panel, or whatsoever. This will come out as a result of this question and answer game that we do with your site engineers. So, you see, outages are not a problem, as long as we know how to tackle it. Then we come up with solutions, with proposals, and we take it from there. Now, what is the typical pumps that we have in water procurement? These are standard norm pumps, the first and the second one. As everybody has them, because we are certified, we also have to offer them as a standard. This is not our core technology. Standard pumps, you can get them cheap somewhere. Hopefully some of them are reliable and durable. Ours for sure are. There is one specialty. This is a standard pump where you not have a shaft, a coupling and the motor, but it's all in one block. The motor is on a stub shaft on the pump itself. It comes as a block package. It is helpful to reduce built-in sizes. This one, I would like to show you a movie on that. An axial split case. It's good for large quantities of water being procured, large flow. These ones we have typically as intake pumps. Some of them are right now manufactured for Davoise, some others are to come. And the multi-stage high-pressure pumps are very good and effective, very energy effective as booster pumps to transport over great distances and to greater heights. As you can see, the technical data range differs quite a bit. Here we have about 4,000 cubic meters, here we have about 800, but the pressures are different. 40 bar compared to 16 bar. As I say, 65 to 70 different families of design give us a huge range of applications. And sometimes if we are receiving inquiries, our technical department works for about 2 weeks on one quotation, just to find the best solution for your application. And you will receive questions on that. This is some other actual vortex types. These are bigger sewage type pumps that are also very tolerant in heavy containment of solids. This is a little side effect that we're doing in sewage sump pumps. And as I said, water procurement in boreholes is quite often done in the submersible pump technology. It's not restricted to boreholes though. Sometimes you can just lay it down in the riverbed with a casing if need or if there is a technical advantage to it. I'll give you an example later with the modular technology. Now, this can also be used as booster pumps because this technology here, a conventional submersible pump, gives you a head of about 350, 450, maybe 500 meter. Sometimes you have mountains to go up or stations that you have to feed over large distance. And here is a technology that gives you, and we have a world record there, I'm proud about it, 5,500 cubic meters an hour on 1,600 meters head. 1,600 meter head in one stroke with one pump. This is world record. And I tell you the technology behind it somewhat later in the presentation. So if you have large distance, if you have a problem with your pipelines, or if you have extreme problems with the heads, that one can do it. I can assure you on one thing though, this baby costs a bit. I can assure you also, this baby earns money much more. It comes from the mining technology. It's spread out worldwide. In Germany, we have a very great mining company that works close to us and allows us to do test runs. One of those beasts was in service 38 years without being pulled. And then it went for refurbishment and goes in for another 15 to 20 years service. Modular technology. This is one that you might probably like if you have changing frame conditions or different boreholes of the same diameter but with very, very different water levels. This was a picture taken in a German client's facility. These are all spare pumps. It's a big mining company. They have different holes with different water levels, and for each borehole they need one spare pump just in case as a standby. Now, why do they have it? One pump can do small water heads, one bigger, one still bigger, one very big water heads, but you cannot use the super big for the small levels. It cannot operate there properly. It's without the duty range. It would be really nice if you had a pump that can breathe with the applications. Now what we came up with, I wish I were it, then I would be wealthy, was to put a modular system. There is not one solid shaft with solid impellers fixed on there. This pump comes in packages with models. Casing, stub shaft with the impeller. Now, if the water level goes down, if you need higher heads, you take the pump, add one module, screw it on with, I think it's 12 screws up to 24 in the bigger sizes. If the water level goes up, if you don't need that much head to be pumped, you remove one or two sections. If you have different boreholes with different water levels, some of those modules only is the stock keeping. These are the spare parts. You don't need to hold back all spare pumps. Just a few modules and maybe one or two motors, one for the smaller heads, one for the bigger heads. So this is the former situation of stock keeping. Some modules, one or two motors, maybe a cooling jacket, that's it. End of stock part keeping. And the pump is very flexible also if there is a clogging. Typically the first and the second stage of a pump are to be clogged. Now I told you about downtime. If you need to have a spare pump, or if you don't have one, you pull the pump, have to dismantle them, have to disarrange them, you have several days of downtime, no production. Here, with this system, you take the first and the second stage out, take new ones in from the stock, some modules, put the pump back in service and clean the two models and put them back in your stock. I think that's a very brilliant idea. Third, to pumps not being the only part in a pump system. In terms of efficiency, the pumps need to be tailor-made, or I would recommend them to be tailor-made to the application. I would recommend the coupling with the motor to be tailor-made for that very pump. I would recommend the controls panel to be custom-made and designed for this motor, coupling, pump, pipeline application system, and that's how we squeeze out that efficiency of 85+% in the best case. Up to 6,000 megawatt. 6,000 kilowatt is 6 megawatt. So the bigger ones we do all ourselves. Typically they are rewindable. The submersible motors are all water-filled, and we have a couple of patents in here that allow us to use our motors in severest conditions, where other motors heat up and burn out because they cannot get the heat out of the anchors. We have a forced water flow inside the motor. The coolant always carries the heat out to the cage. If that's not enough, there is cooling jackets the water can also flow through the extended surface of the cooling jacket, thus getting the temperature out into the surrounding water. So the motors can survive under stronger conditions or in warmer water than other standard motors can do. Now this is a little exotic thing. Normally one thinks a pump manufacturer has nothing to do with the pipelines, but in terms of efficiency we think we have to. Why? This is a standard pipeline in a borehole. It would be so nice if we could use all this borehole diameter for water procurement, but we lose a lot due to the flange diameter. So this is the borehole, this is our losses due to the flange, and this is the little thing we have left. This elephant is not quite happy. A second thing in classic flanges is assemblage time. As you can see, these are pictures taken from some site, I'm not quite sure where in the desert, but you see with extension and all kind of aids, they try to really firmly tighten nuts and bolts. Now if you do that around this flange, it takes you maybe 15 to 20 minutes per connection. Then you have another 10 to 12 meters pipe done, another 20 minutes, 10 meters, 20 minutes. So this pipeline takes about a week till it's done. Imagine flanges of that size. You get that pipeline never done. Now the first problem, the diameter, could probably be tackled with threaded pipes. You know them from boreholes, borehole drillings. Yes, you get a better diameter ratio compared to the borehole. The problem is this threadings equipment is very delicate because you need a clamping, turning, rotating, counter clamping, fixing, whatever device, and this is easily to be broken and it's costly. This is just a plug-in and quick fix idea, as I have it here in the model. You basically have a plug-in module with a few sealing elements. This is just the principle, it's not an exact detail copy. You basically set the pipeline connection. This is a linking chain. Actually it's fixed with two, but this is how easy it's fixed. The other one is symmetrically on the other side. End of story. Pipeline done. And because you can now claim that yes, this is a principal model and this is a gameplay and whatsoever, this is an actual movie with two original pipelines during a certification. This certification was a pressure test for our strongest pump, the one with 1600 meters head. So this was a certification pressure test, 160 bar. And now I would like to see you how things are assembled. This is the whole connection of the pipeline. So about 12 seconds. Let's give it 20. End of story. Now it's pressurized. It's fully operational. That was it. The pipeline is done. You sink it down into the hole again. Next 20 seconds, 10 meter, 20 seconds, your pipeline is done in a few hours and not in a few weeks. And because I was asked in a previous presentation whether this chain is damaged somehow or deflecting, bending, or due to any external forces, I have caused another video to be done after the pressure test, the disassemblage. That's how you disassemble this pipeline. Now, just to recollect, this is just a side effect. This is not the main focus. Of course it's a nice effect to have a quick assemblage, but borehole costs money. Very, very much money. Now if you have this borehole in the flange and only this little bit of pipe left, that's a bad ratio. In this case, the same pipe, smaller borehole, or if you have the borehole already, you have a bigger borehole, and of course a lot more water coming out of the pipe. A lot more water of the same pipe means more water you can sell, more cash intake. More water in the hole means lower velocity, less friction losses, less energy. You pay less to the power grid. You save on both ends. The more questions you answer in the process in the beginning, the more you invest in brains, the better will the solution be. And I'm extremely proud when I joined Ritz company and traveled all throughout the places here, that some people still remember that there was some water station where still some pump is working for 30 plus years. It must have been a Ritz pump, and now it would probably be about ready for refurbishment or replacement. That makes me really proud. Ritz considers itself to be a consultant in pump solutions. We're not just the salespeople or traders of something. We would like to enable you to ask the right questions. You can use the questionnaire and ask different pump manufacturers on the questions. They might probably tell you, I've never reflected upon it, I've never heard those questions. But we come here also to give you training. Our service people can invite the station supervising engineer or super engineer or expert into Germany to do training in our headquarters. They learn how to assemble in the manufacturing the pumps if they like to. We would like, and I think this is a nice idea, with every station that we can probably serve with Ritz pumps, invite the station manager and the chief engineer in for practical training. We come also here to Ghana and do practical training either here or in other facilities of AVRL. We're prepared to help. We have a representative here in Accra, which is Internert, Mr. Eric Johnson. He has a troop of very well, expertly trained people that help in emergency cases as troubleshooters. If something blows in a pump station, he can basically jump his boys over there, and in 2-3 days, at least the thing should be running again. Now I'm ready for
time.
questions.
I'll tell a question in Greek, and then we'll drink it. So I will finish with this particular one, then we'll go to the next. Not to me. Are you asking me a question? Okay, please.
I'm concerned about your lead times. Supposing I'm in my office and they come up with an emergency requirement for pump.
Yes.
And how best can you meet lead time? But I know I put an order for Ritz pump and it was like 46 weeks or so delivery.
Yes.
And you have some pumps off the shelf where you can easily tweak in terms of emergencies.
Ritz has no pumps from the shelves. We have done more than 1 million pumps worldwide within the last 130 years. Almost each is individually tailor-made. We cannot hold for each application a spare pump. Our stock would be incredible. It would fill the whole village. We cannot hold back a spare pump over 1 million times. But as you can see in the movie that I'm about to show now in the break, the pump families are of alike design. If we know the ID number, the serial number of the pump, we know each individual pump the last 45 or 50 years at least back by name. We know what is done with it, how it was tailor-made, how the impellers were treated, how the bearing solutions came up. So if it's a familiar family, we should be able to manufacture, say, an impeller within a few days, say 2 to 3 weeks. It can be, though, if it's a very rare or a very special big pump, one of size this or bigger, okay, this one is an easy one. Then we have to do the sand negatives, then they have to do the special alloy, the metal alloy to it, then you have to cast it, it has to cool down, it has to settle, because the cast, when out of the form is not ready, it changes, like wood, it starts to live, and then we can just do the surface milling and grinding, honing, ore drilling to it. That might take a while. But if it's a special material, then I have to admit it will take time. If it's an emergency, it might be that Eric and his boys can do something on site just to immediately troubleshoot. It could be that maybe for the time in between until the good pump is done again. Yes?
Yeah. Please, with the modular shaft system, if you vary the number of stages, what becomes of the driver unit? I mean the motor. So you also have to vary.
Yes. You can operate with the same motor if we know up front that there is varying conditions. If you let us know, not only this is the desired duty point, but this is the maximum flow, maximum head, the minimum flow, minimum head that might occur, and this is the desired operation point, then we can choose a motor pump system which can fulfill this variety. If you only give us the typical answer is head, flow, 20 degrees, still stand, pure water. Yes.
In case maybe the water level falls,
Yes.
and you may have to reduce the number of stages, will you have
Increase in that case. Yes. The level changes that might occur, we might come up with a solution that can cope with it with one motor. Say we have 10 modules in the pump and we go to 13. Then we can take that into consideration. Of course, if we are up to 25, 27 stages, you need a different motor.
Yes.
That one is very clear. If you have different boreholes, for instance, with different heads, then I think it would be a good idea to give you the details of every single water hole with duty point, maximum point, minimum point. And then we can probably suggest a variety of, say, 3 or 4 motors with the modules, at least a minimum that you need to have on stock. So I think then we go very much into the details and our experts has to start calculations. But one motor can survive about 2 or 3 stages difference. If we need it up front, maybe more.
The slips, what is the range, the length?
Standard range of a pipeline lies somewhere between 10 and 12 meters just because of transportation. Typically they're done in containers or in bundles. They can be done longer. They can go up to 20, 22 meters if need. This is unusual size. It will cost you probably a lot in transportation because this is extra bulk. Standardly it's between 10 and 12 meters, but it can be done in different sizes as you desire.
Many times when pumps are procured, they don't come with customized literature. And I mean, the literature that comes with a pump is not specific to that particular pump that has come. And it offers nice maintenance personnel. Because what you tend to have is what we call the series literature, which doesn't go to specific components and identifies specific parts. So it becomes a problem. Do Ritz normally give customized literature as well with the, or as usual, we also give the normal series literature that goes with a particular design?
If there is a specific request, but I don't see right now from by heart what the reason could be, because every single pump within the family is basically a family look alike. The sizes of the impeller are different, the shapes are differently grounded, but this is not something that you would normally have to consider in a maintenance manual. but each individual pump comes with its own original literature, with the maintenance, and this is probably a good point where I could shuffle in the movie. This is one of our basic training movies. It gives you a nice insight inside the pump, how it is principally done, of which part it consists, which ones can be replaced, and how the thing is assembled and disassembled. And there is, like with this movie, also in the manual, in pictures, in standstills, some background for your engineers. Also, I mentioned, we gladly invite your people to be trained, either here on site or in Germany. Quite a bit, more than 50. So I think there is ways and means how you get people trained.
When you are bringing a pump to the customer, attach the
full documentation.
Full documentation of that particular pump. Absolutely. Or the series of pumps that you, or the family.
It is something that I would like to explain, and probably going a slide up here. Say if you have a high pressure pump, they're all lookalikes. There is two different designs, one is the 45, one is the 49. There is one family maintenance operation manual. There is, every single 49 pump looks alike. So the family thing is basically an individual manual and instruction for this very pump. 149 looks different from another only in the number of stages, but they're all identical. The place of the sealings, the place of the bearings are all at the very same place. So that is in the manual, that is individual. The shape of the impellers is not probably too useful during the maintenance process, because you have an impeller of that diameter, you plug it in and that's it. So the differences of the pump, the custom makes, are in the detail shape of the shuffles, I would say. The maintenance, the manual is the very same for every single 49er pump, and each 49 pump gets the 49 manual, gets the drawings, gets the designs, gets the instructions. Each 45 gets the 45 instructions, the 45 manuals.
In April 2007, there were 6.6 billion people on the planet. Every day this figure grows by 213,000. That's nearly 78 million year after year. The world's rising population is creating an appetite for resources that is proving more and more difficult to satisfy. The most vital resource of all, this liquid gold, is becoming increasingly scarce. Ever greater quantities of water need to be transported, often over very long distances. As quantity and distance grow, greater demands are placed on the pump technologies of tomorrow. Here at Ritz, we have defined a new benchmark for these kinds of pumps. Long service life, straightforward maintenance, flexibility, maximum efficiency, extraordinary NPSH values. These were the points of focus when it came to developing the innovative new pump. The result is a product that not only guarantees minimal operating costs, but also protects the environment. The environment will thank us. The new ASC, designed for superior performance. ASC, axial split casing pumps that are tirelessly hard-working, developed for the hardest tasks, to pump huge quantities of untreated, pure and processed water, as well as mineral, lake and seawater, at waterworks, pumping stations and power plants, and for use in fire extinguishing systems, marine technology and the petrochemical industry. Discover the numerous special features of new ASC now. The flow channel on our ASC was developed using the latest technologies. The benefit? Maximum efficiency minimizes operating costs. Axial thrust and the resulting load on the pump bearings are reduced to a minimum thanks to the double flow radial impeller. The result? Minimal wear and maximum service life. The computer-optimized flow channel and extra-large impeller inflow areas ensure inflow rates are ideal while delivering great suction characteristics and an extraordinary NPSH value. The short drive shaft is guided on large, lubricated bearings on both sides. The benefit? Greater stability, quieter operation, and lower vibration, and therefore a long service life. The symmetrical design and identical components allow the drive to be positioned on both sides. Modifications can be made with no additional parts or changes to the product required. When it comes to sealing types, Ritz offers both a proven gland packing and a maintenance-free mechanical seal featuring high-quality design. Identical seal casings make it quicker and easier to switch to a different type of seal. A choice of materials and material combinations delivers the flexibility to adapt to specific conditions. The short drive shaft, double bearings, and double flow impeller ensure maximum service life. To minimize maintenance costs even further, wearing rings and sleeves protect all essential parts. Thanks to the axial split casing, the pump does not need to be removed from the pipe system in order to perform maintenance tasks or inspections. Simply unscrew and remove the cover. The top part is easy to fit thanks to automatic locking. The pump is fitted into the pipe system either horizontally or vertically, based on an inline design. The suction and discharge branches are situated opposite one another. Depending on customer requirements, different standards can be used for the bores on flange connections. The medium being pumped flows via the suction branch into the optimized flow channel. There it is pumped via the double flow radial impeller in the direction of the discharge branch. Key benefits of ASC. An overview. Long service life, easy to maintain, flexible, maximum efficiency, and extraordinary NPSH values. The bottom line is minimal operating costs. Or just said in one sentence, ASC, designed for superior performance.
On the cost of energy, I think looking at where we are heading towards, especially in the case of Ghana, every serious businessman will be thinking of energy costs. You mentioned that we can have about 15% savings in terms of efficiency in the brands you make. Has there been any benchmarking that you have made, and are there any empirical evidence?
This is a very, very good question. The important thing I would recommend. With every single pump that you have in operation, you could do an energy audit. You check how much power you put in and how much water you get out. The power tracking, you know, a similar thing you have in the car. It tells you how many kilometers the car has run already. It clicks just click by click by click, and you have a sum. With a power tracker, you can do the very same thing. You put it in the line between the control panel and the pump, or you install it in the control panel, and it clicks. And I would recommend that either on a daily base or at least a weekly base, you look at the figures, you see how much power that system, pump plus coupling plus motor plus pipeline, how much power it has consumed over that period of time. And on the output side, you have a flow meter. And then it's an easy calculation. The ratio power water out compared to power in, this is your efficiency. For two reasons I would recommend that. Number one, because Ritz is not ashamed any competition in the efficiency. This is a good sales argument for our efficiency pumps. Number two, if the ratio changes, if you get less water out or you need more power for your output, then your maintenance people know there is something about to be done. Something's going wrong now. Because it might be that the impellers are clogging, or you have friction that increases, you have additional wear somewhere in the system. If that ratio changes, this is an alert sign for you. Secondly, what I would also suggest, and we just came up with that recently, that I try to equip Intermerk with 2 or 3 of those power trackers that he can go around and mobile power auditing. He just basically goes in between the control and the pump with the power tracker, and if there's a flow meter, you can calculate the efficiency of the system. Then you also see where the losses are. And in these days, where energy is extremely costly, every single % is money. So you do power auditing. I would recommend to do it built-in or maybe mobile, but then continuously coming back and do it on the same installation too. Thank you, Lord. Very good question.
As added on, wouldn't you want to equip GWC or AVR rather with the power tracker, and then you train people, because your rep will not be everywhere at the same time?
Absolutely. I think it's the best. With every single refurbishment, we could either upgrade the control panel, or if it's replaced anyways, it's built in. It's, I would say, not quite a penny article, but it's fairly cheap. We're in the range of a few €100 per power tracker. That one is paid off in a few days if you see that the efficiency is bad. And then it enables the station manager, the station engineer, to really see the figures on a continuous basis. He can do his daily, weekly and monthly tracking and energy audit internally.
You also mentioned in your presentation that I think, I don't know to what amount you invite people for training in Germany, but I remember about 2 years ago we made an installation at Dawasi, and if that is true, then you are owing Mr. Makujo and his people some trips.
At least I would love to invite, basically with every installation, at least the station manager and one of his engineers in. For sure, if the engineers are invited, Mr. Gambra of course is invited, and the head people, the managing directors of both AVRL and of Ghana Water have to know where we invite the people to get a taste, to approve it, to see what we are doing, to see our nice facilities, probably to also see why we are so proud of our work, what the advantages of in-base training in the headquarters are. I would say for sure they are more than invited. Absolutely. Thank you.